Good afternoon, students. Sorry. At the end of the lessons of second part of 10th one, communication system. In this lesson, we will see the following topics of basic element of communication system. What is the need for modulation and its types? In propagations of electromagnetic waves through space. These are the topic will be we are going to see the lessons. Okay, so first of all, communication. So communication is nothing but it is the dawn of life in this world. Growth in science and technology removed the locational advantage or disadvantage of effectively information can be exchanged from one person to another person anywhere on this earth. Right from the developments made in communications by great scientists like J.C. Bose, N.G. Marconi, and Alexander Graham Bell, communication has witnessed leaps and bounds. So, the communications industry is the one of the largest in size and is the oldest sense of communications through telegraph in 1844, telephone 1876, and radio 1887 started the centuries back. The intensive research in the mid at the 19th century leads the development of long distance transmissions of the possible, which means short possible time. However, the 20th century witnessed a leap over the development of communications like GPS, satellite, mobile, and optical communications. So, in this unit provides a glimpse of the basic concepts of electronic communications and its applications. So, first of all, we are going to see modulation. The modulations in this topic, the transmission of information through the short distance does not require complicated techniques. We know that the energy of the information signals is efficient, which means sufficient enough of it to be sent directly. However, the information, for example, audio frequency, we know that we are hearing audio 20 Hz to 20,000 Hz needs to be transmitted at a long distance across the world. So, certain techniques are required to transmit the information without any losses. So, modulation. What do you mean by modulation? For long distance transmission, the low frequency baseband signal is nothing but input signal. The input signal is superposed with the high frequency radio signal, is called as modulation. So, high frequency signal is called as carrier signal. Once again I repeat, baseband signal having a low frequency is called as input signal. The high frequency signal is called as radio signal or as carrier signal. At the frequency of the carrier signal is very high, we know that. It can be transmitted to long distance with less attenuations. Attenuation is nothing but, which means a loss of energy. The carrier signal is usually a sine wave signal, and also the carrier signal will be more compatible with the communications medium like free space and can be propagated with greater efficiency. Okay, so the sinusoidal wave, which means sinusoidal wave, can be represented as E is equal to capital E is sine 2 pi nu c t plus the phase angle phi, whereas E is nothing but amplitude of the carrier wave and nu is equal to frequency of the carrier wave and phi is the initial phase of the carrier wave at any instant time t. Three characteristics in the carrier signal can be modified by the baseband signal during the process of modulation. First one, amplitude, frequency and phase of the carrier signal. There are three types of modulation based on the parameters is modified. They are amplitude modulation, frequency modulation and phase modulation. The first topic, amplitude modulation. If the amplitude of the carrier signal is modified in proportion to the instantaneous amplitude of the baseband signal, then it's called as amplitude modulation. Here, the frequency of the phase of the carrier signal remain constant, which means the carrier signal frequency is constant and phase also constant. Only changing is the modulation, which means amplitude. So the baseband signal carries information. The high frequency carrier signal, the diagram will be provided here. The first diagram tells us baseband signal carries the information. Second diagram tells us high frequency carrier signal. And third diagram tells us the amplitude modulated signal. Okay. And then next, advantages of amplitude modulation. Here, the transmission and reception is very easy, lesser bandwidth requirements and low cost. And limitations of amplitude modulation, noise level is high and low efficiency, and finally small operating range. And second modulation, frequency modulation. The same way here, the frequency of the carrier signal is modified in proportion to the instantaneous amplitude of the baseband signal. This is called as frequency modulation. Here, amplitude and phase of the carrier signal will be constant, only changing the frequency. So, increase the amplitude of the baseband signal and also increasing the frequency of the carrier signal, vice versa. This leads to compression and rarefactions in the frequency spectrum of modulated wave. Show the figure here. Louder signals lead compression and relatively weaker signals of rarefaction. So the final diagram tells us compression and rarefactions will be occur with respect to the frequency. So amplitude and time will be various with respect to the frequency modulated signal. When the amplitude of the baseband signal is 0, the frequency of modulated signal same as the carrier signal. So the frequency of the modulated wave increases with increase the amplitude of the baseband signal increases, which means positive directions like as AC. Here A and C are the positive amplitude directions, and here B and D are the negative off cycle, which means reduces the frequency of the modulated wave. So when the frequency of the baseband signal is 0, which means no input signal, there is no change in the frequency of the carrier wave, and it is not of our normal frequency, and is called as center of frequency or resisting frequency, which means resisting frequency, and this value will be 7 kilohertz. This is the one more questions of important one. The resting frequency or center of frequency value will be 75 kilohertz. And then advantages of frequency modulations. Large decrease in noise. This leads to increase the signal noise ratio. In second one, the operating range is very quite large. In third one, the transmission's efficiency is very high, as all the transmitted power is useful. And finally, the bandwidth of frequency modulated wave covers the entire frequency range with the human hair cure. Due to this, FM has been better quality compared with the AM radio. In the limitations will be provide FM. FM requires much wider channel. In transmitters and receivers are more complex and costly. FM reception is less area is covered compared with AM. And finally, end of this lesson, we are going to see the topic of phase modulation. This topic will be covered and the entire lessons will be covered in this lessons of communication system. In phase modulation, the instantaneous amplitude of the baseband signal modifies the phase carrier signal, keeping the amplitude and frequency will be constant. Here the diagram will be provided here. So first of all, the first diagram tells us the phase modulations, and second one tells us carrier signal, and third one tells us baseband signal with the phase modulator signal. So the same way, having the carrier phases of changes according to the increase or decrease the amplitude of the baseband signal. When the modulating signal goes positive, the amount of phase leaves increase with the amplitude of the modulating signal. So end of this lesson, the frequency shift carrier wave frequency is the phase modulations, as well as the frequency shifts depend upon the amplitude of the modulating signal and the frequency of the signal here. So advantages: frequency modulator signal produced from PM signal, which means phase modulation signal, is very stable. And second one, and last point also, the center frequency is called as resting frequency, is extremely stable. Okay, dear students, this is the end of the lesson. So just we go through the lessons of what are the three types of modulation, like as amplitude, frequency, and finally phase modulation. Thank you.